All this sense of there's not enough spec is all about the under 3 gigahertz range. And there's only 3 gigahertz of spectrum under 3 gigahertz. But once you give up on that and go higher, there's like a lot of bandwidth sitting there up in the millimeter wave. It's not infinite, but like it's going to take a while to run out of bandwidth up there.
Yeah, and I think even with the regular bands, there's a lot more that we can do. You're seeing it with Wi-Fi with like multi-user MIMO, and a lot of that stuff is in 5G, but you can actually have multiple devices transmitting on the same frequency at the same time. And if you have enough antennas at the receiver, and in the case of 5G, you have these big phased arrays. You have 4,000 antennas at the tower. You can sort of pick and choose and just receive signals from the individual devices, and they're all using the same 25 megahertz at the same time. They're all broadcasting at the same time, or the tower sending it to them all at the same time on the same band. If you have enough antennas, you can kind of pick exactly where you want it to go.
The Starlink dishes, that antenna you put on your roof, is not an antenna. It is 1,280 antennas arranged in a grid. And software combines all those, software and hardware, combine all of those signals to make it instead, send a almost beam-like radio wave out. So somebody, even a few hundred feet away, aimed at a different satellite, their beam and your beam might barely interfere with each other. Right. There can be a lot of people in the same area using the same spectrum if you're serious about proper antennas and things, which they are these days, right? We've gotten very good about that. And if you stop people from being ridiculously badly behaved, you make them follow a little bit of sharing rules and not act as active hogs, just using as much as they want, not more. So what does it mean to own spectrum? I mean, SpaceX is paying $17 billion to own 50 megahertz of spectrum. What does that actually mean?
So, especially when you get global, that's really tough. So in the US, basically, the government kind of came out owning all of the radio spectrum, and then they decided what to do with it. Then they would hold these auctions where they would say, okay, so this 80 megahertz chunk right here, military used to use it, they don't need it anymore, so we're going to auction it off. And they'd say, okay, all these companies, get your bids ready because we're opening it up at this 80 megahertz chunk of spectrum that's no longer going to be reserved for the military. You're going to be able to do whatever you want with it. And so there's these nationwide auctions like that. And then there's also, if you are looking to sort of start your own cell company in Nevada or whatever, there's regional auctions where you get the rights to cover, this third of a state. You can, get these bands, and it comes down to kind of a contract, usually with some sort of time on it. Okay, so for the next 20 years, you have the rights to use this spectrum.
When you say Starlink bought these rights from the government,
right?
So it's the U.S. government, right?
So for some other stuff,
this is not worldwide, right?
Right. So I think what they just bought, they bought from EchoStar, right? So they bought from another company that bought from the government like 20 years ago or something.
Right. So this is not worldwide 50 megahertz. It's the United States they bought.
I think that's right. But it's, when you're operating in space, that stuff gets weirder.
Yeah, I don't know what the rules are like over oceans and things when you're in international waters. Ryan asks, what is millimeter wave?
That millimeter, they're really talking about the wavelength.
The light has a wavelength of about a millimeter. That means it's up around the 10 gigahertz. It's that whole area up there, the KU, the KA band. So as far as I know in the US, I think Verizon is still the only carrier that supports millimeter wave. They call it their Verizon UltraWide band. If you have Verizon, exciting for you. If you don't have Verizon, I don't think it does anything for you. And it doesn't penetrate walls and stuff, but if you can get a good view of a tower, it really will give you this, not a 5 megahertz wide signal, but apparently they'll let you very temporarily grab hundreds of megahertz. They claim it's ultra-wideband. As far as I know, the definition of ultra-wideband is 500 megahertz. And I haven't been seeing people saying it's false advertising. So I think they really do let you grab 100 times as much bandwidth if you have a view of the tower. So it can be really cool, but you can't count on it. Sometimes you get those speeds, most time you won't.
So I've seen a couple gigabits with it on my phone. If you're lucky enough to be in a spot where you own most of a tower, you can really see 2100 megabits or something on speed test. It's pretty crazy. It's pretty neat.
That is crazy. Yeah. I'm on AT&T. I see all these announcements about how they're so fast and they do 500 megabits and stuff, but I get 10. And I'm actually fine with it, right? But I don't see numbers like people they post in their ads. I'll just say that. Bandwidth grows with higher frequencies, but the signals get more prone to reflection disruption. Yeah, interesting. At the lower frequencies, you get crazy stuff. You go below 100 megahertz, and the signal will end up following the curve of the Earth, and you can pick up people in Russia from Philadelphia. Yeah, and these high frequency things, they don't go as far. Yeah. Keep in mind that the upper spectrum is largely already allocated to airport radars. Most of those are very narrow band, and they're scattered throughout it. But a radar is this little spike of spectrum And yeah, these smart radios know to get out of the way. And some of them, was it 3.6 gigahertz? The radio can't turn on unless it knows where it is.
Yeah.
And it knows where it is, and it goes to the internet, and a couple companies, Google's one of them, it's running a database of you're here, this airport is here, therefore you cannot use the following, megahertz because you could be interfering with the altimeters, the radar, or whatever. And, all the radios at 3.6 gigahertz have to respect that because there is so much overlap, the CBRS band. So it's totally built in. And you're like, okay, there's a 2 megahertz chunk we have to avoid here. There's a 5 megahertz chunk we have to avoid there. And they do. There's so much spectrum up there. You can find us a lot. So, see the news? SpaceX just spent $17 billion to buy 50 megahertz of spectrum. That is a lot. So what is the spectrum?
So the spectrum they bought is all right around 2 gigahertz. So it's all right around 2,000 megahertz. They say they're going to be able to use it to expand their satellite-to-cell service. Basically, a bunch of their new satellites look like cell towers up in space, and so you can be in spots that have no, terrestrial cell service. There's no cell tower around you, but your phone finds a tower, and it just happens to be up in space on a SpaceX, satellite.
So I immediately looked, how much spectrum does Starlink already have? And the answer is they have 7 gigahertz of spectrum they're allowed to use. Some is theirs, some is shared with other companies. There's a bunch of rules, but it's 6.9 gigahertz of spectrum that they're using. 7,000 megahertz already, and they just paid $17 billion for 50 more.
A lot of that spectrum they have makes perfect sense if you're trying to build a network for things in space that aren't too far away from each other. I mean, if you're up at like 14 gigahertz or something, you can have satellites.
That's where their spectrum is. Yeah,
you can have satellites talk to each other just fine, and you can set up these 100 gigabit links between all of your satellites because they're using these nice fancy radio technologies over 1,000 megahertz or 1,500 megahertz, whatever, way up at that band. There's no water in the way. There's no trees in the way. There's nothing like it all works pretty well. But those frequencies are a lot less useful in the real world. None of that stuff's going to go through walls. The spectrum that they just bought, this 2,000 megahertz, that's useful. Cut through walls.
And someone like SpaceX owns a range of spectrum. How do they prevent someone else from using that spectrum?
So that's a tricky one. They may have stuff in their tower to try to look for somebody sort of squatting on their bands, and they may just see that in unexplained collisions, or it may just show up in their radio stats of, okay, something weird is going on at this tower. Then it's kind of up to them to either send a contractor out and look, but they can kind of locate who's doing that.
If they think they've located, the FCC will send a van out and drive to location and see if they can verify it, and they'll go arrest people. The FCC vans are real. They find you and they shut you down. What's so special? What's the special property of this 2 gigahertz spectrum? And I was thinking about the spectrum does have properties. It is pretty good for going through walls. It's got medium distance. But that isn't really why SpaceX paid for it. SpaceX paid for it because it's in the band that every cell phone made today can pick up. You can walk into any store and buy any phone, iOS or Android, and it comes with support for the AWS-4 band and the AWS H block and all this spectrum they just paid for. What's special about it is that there's nothing special about it. It's already supported by existing phones. So that makes it valuable, right? They're not going to make a SpaceX phone. Well, maybe they will. But they don't have to make a SpaceX phone, right? They can do deals with anyone who has a phone and say, get our SIM card, and it'll tell you to connect to our towers. Our towers just happen to be in space. Not all their satellites are cell phone towers, but they're launching more and more that are. And they're up to a fair number. The ones that are our cell phone towers are 400 pounds heavier. So it's not some tiny piece of electronics that goes in there. There's like a cell phone tower's worth of electronics, shrunken, I'm sure, as much as they can. And I bet a lot of that is antenna. I bet a lot of that is some fancy antennas to beam the signal down in such a tight beam that your phone hardly notices that the tower is 500 miles away. Your phone doesn't even need to know that. That's what makes the spectrum so special. One thing that's really interesting to me is, I've read about like LTE and how it works, a little less on 5G. I feel like I know LTE pretty well. It's interesting how completely different the radios on the tower are from the radios in your cell phone. With Wi-Fi, it's not very different. You tend to put bigger antennas and more antennas on your router. But if you rip it open, a lot of times it's the same Wi-Fi chip. They're not radically different.
Right.
It's a kind of peer-to-peer-ish protocol where, the one peer in the router says, hey, I'm kind of in charge. But cellular is entirely different. So a typical phone, for example, in their carrier's band will grab, 5 megahertz wide slice of spectrum. And, time division, they get turned. You go, then the other guy goes, and you go, then the other guy goes, and so two of you can share the spectrum. But they'll have a bunch of bands. So here there's like 50 megahertz of bandwidth, and they probably divide it up into 10 5 megahertz channels. They have some options. They can go narrower, but then your internet gets slower, and then go wider and give you faster service, but then they can support less devices. But, 5 megahertz is a typical choice. And so you've got a radio in your phone that does 5 megahertz, exactly like you would expect. There's no 5 megahertz radio in the tower. It's running a 50 megahertz wide radio that is picking up one signal that consists of the data from, 10 different phones. And it treats them as one signal. It runs them through the filter together. It runs them through the analog to digital converter together. They're not split until the data reaches the CPU, who then pulls apart that the first couple bits must be from the first phone, the second must be from the second, and they're totally different. And so, for example, the cell phone tower tells the phones to adjust their power level. And they're not telling them to adjust the power level to, make sure your signal gets to me at full strength. No, they're telling them to adjust the power level so that the signal of every phone they're talking to hits the tower or the satellite at the exact same level. Because to the cell phone tower, it's just one signal. And so it doesn't want part of the signal to be louder than the other. It needs it all to be one level because it's running through one amplifier, one filter, one analog to digital converter. Because to the tower, it's a single 50 megahertz signal. Crazy stuff to me. When can we expect a full rollout of Starlink cellular service for all major US carriers? Or is it like an exclusive deal Starlink made with T-Mobile? I am seeing articles talking about it is coming to AT&T and Verizon, and that is going to cost more than it does on T-Mobile. It's like an extra $15 or $20 a month if you're on AT&T or Verizon to have the satellite service, so you can go anywhere and still have service. So I think they have some sort of deal where they didn't quite promise T-Mobile that it wouldn't work with anyone, but I think they did promise them it would cost more. So that is what I'm reading. It sounds like it could be pretty soon. I don't mean days.
The interesting thing is, though, it's just a contract issue, right? It's not like they're going to have to put up new satellites to support Verizon or whatever. It's just boardroom stuff. So in that sense, it's good. We just need SpaceX and Verizon and AT&T to sort of hash out the terms, and they could turn it on Monday if everything was in place and they agreed it. So
yeah, I think that's correct. I see the value when somebody falls and hurts themselves in the Grand Canyon and being able to call for help. But I've always enjoyed the fact that there's places I can go where my phone doesn't work. And Brian cannot reach me. Sorry, I'm in the Grand Canyon.
Apple just pushed out their satellite, different than the Starlink satellite-to-cell thing. But another year, you can use it for free if you need to make emergency text, right? I haven't actually gone through have you done the test mode thing for it? I haven't yet.
My phone is too old.
Okay, all right.
I need to buy a new phone. But yeah, so the Apple's thing is kind of different, right? They're using a company called Globalstar. And last I checked, Globalstar only had 31 satellites. Starlink is up to 9,000 satellites. If you look up, you're always looking at a couple Starlink satellites. They have so many. But the Globalstar that Apple just invested $1.1 billion into is still down in the 30s of satellites. So it's a kind of different experience. You get outside, and the T-Mobile ads are making fun of it. You have to stand there with your arm up until your phone finds a satellite, and then you get to send one text because, there's everybody sharing 31 satellites. There's not a huge amount of bandwidth. But, if you have fallen in the Grand Canyon and broken your leg, you really only need a couple texts. So I'm not sure that's terrible. I've never used Starlink cellular service, and I've never used Starlink's internet in general. I use Spectrum for my home internet and for my cellular, but I've always been curious about the service. So we have 2 dishes on the roof here and one at Kevin's house because we have a lot of customers using Starlink. It has rapidly improved. It's also gotten more expensive. A year ago, we were seeing it, stop working for 15 seconds every day and get really, really slow a lot. It's gotten more consistent as they've added more and more satellites. And 2 months ago, they added the new mode where it's a lot more smarts. And I got to give them the credit for this. It's talking to one satellite but it's also in software tracking the location of another satellite. So if it loses the first satellite, it can switch in something like 100 milliseconds to the second satellite. And that has actually seriously changed their stats. The people where every time, they're tracking a satellite and then it goes behind the tree and then they have no internet for the rest of the 15 seconds until it switches to the next satellite. Now every time the satellite it's talking to goes behind the tree, it hops to the next one, hops to the next one. So it's made a big difference. We typically see speeds 300 down, 50 up. It's okay. We really got to recommend that, Starlink plus anything else is fantastic. So if you tether your phone and you use Speedify or even pair and share, so when the Starlink does glitch, and it does, Speedify can kick in with second connection, even if it's slow, right? I mean, the difference between being offline for 15 seconds and being only 2 megabits for 15 seconds, that's like a world of difference. Like, you get blocky in the call versus you hang up on the customer you're talking to. That's a big difference. So Starlink plus anything through Speedify, clearly something I recommend.
Yeah, there's a lot of times where the upload sort of gets pegged at 5 or 10 or 15 megabits for pretty long periods of time where it's tough. I mean, I don't do that much uploading, but being stuck at 5 megabits, I notice it. That's where you start jiggling cables and stuff.
Yeah. Yeah, the other thing is they've quietly made it much more expensive by tweaking the terms and conditions. The Starlinks here, whichever plan they were on, it used to be that if we used too much data, they would slow us down. Well, now they cut us off. Like, right, okay. And so we actually had been okay with, all right, sometimes at the end of the month our Starlinks get slow. But now it's an issue. So having some ability to shove some of the traffic to something else, even if it's slow, if you don't need much internet, not using that extra expensive bandwidth on it is good. I'm a truck driver. I have ART and T-Mobile hotspots and always fly Speedify. Yeah. The difference between one connection and two connections is so big because every one of these carriers has dead spots, but they're generally not in the same places. Right? I discovered this. There were some videos of mine that got a bunch of views where I was riding the train between Philadelphia and New York City, and I had AT&T and I had Verizon, and you could see they each glitched, but there really were no spots where they both glitched at the same time. So super excited. You could go all the way between Philadelphia and New York without losing internet, except in that last tunnel under the Hudson River. Although I think they fixed that now. I think they've all put, cell phone towers in that tunnel. AT&T and Verizon, that's pretty good. Some of the MVNOs, if you're getting the MVNOs, they have cheap plans. You do have to kind of look a little bit, right? They kind of all are a little slower, and they're also sharing a network with someone else, right? There's AT&T, Verizon, and T-Mobile in the U.S. And in some corners, there's U.S. Cellular. Not in any of the major cities. All the places where, cell phones don't work. Sometimes U.S. Cellular does. But so all these MVNOs, you see, there's Visible. That's really Verizon. There's Cricket. That's really AT&T. So combining Cricket and AT&T probably doesn't get you what you were imagining. I never used Starlink cell service, but did have their Starlink satellite at a campground deep in North Carolina. It was awful.
Yeah, I mean, if you have a full campground of people, they're all sharing upload that's something like 10 megabits, I could see that being rough, but should be pretty good.
Campground North Carolina, for Starlink to work right, it wants to see a lot of the sky. There are forests in North Carolina, and so there's certainly some possibility that it wasn't seeing enough of the sky. And as I said, very recently, there was a software update where it's a lot better, right? It's always ready to switch from one satellite to another. And so there are a lot less gaps in service now. But, combining things, 2 Starlinks, a Starlink plus a cell phone, Starlink plus a DSL, I mean, it's radically better. The little Starlink glitches don't matter nearly as much. When are we just going to have AI to AI calling? ChatGPT, call mom.
I think we already have it.
I think that exists. I think that's the majority of what's going on the internet is chatbots talking to chatbots. Marketing products for people to other robots. I keep sitting down and being like, I'm going to do it. I'm going to vibe code. And I come up with a problem that the AI ought to do. And at the end, it doesn't work. And it keeps happening. I've thought it's me, and I watch all these videos about vibe coding and stuff. And everybody on the internet seems to swear that it works great. As far as I can tell, it's garbage. And I saw a very interesting stat that if you look at the sites where people launch new products, like Product Hunt and stuff, there has been no spike in new launches. For all these people talking about how they built an app in one day, there should be more apps launched. There are not. So I'm going to say there's a whole bunch of hype. Riley says, 30-year developer here, and the vast majority of vibe coding is garbage. But things are getting better, and for limited cases, it's getting usable. Totally believe you. I mean, we do old Speedify foreign language support at this point is OpenAI. We're letting the AI translate. People reach out to support occasionally and say, oh, this is a terrible translation. And we redo it, and then we have the better translation from then on. For that stuff, it really seems fine. Translation's 100% useful. Yeah. For translating stuff, the chat stuff is good enough. Yeah, we've got like the chat bots running, doing code reviews on all of our changes, and some of them are just comical. I mean, that review the other day where it said, the comment says that this turns off this feature, but in fact the code turns off this feature, and you should change it so it turns off this feature instead of turning off this feature. Where did this come from? I told the developers to reread that code very carefully because perhaps there was something odd going on that had sent the AI off the rails, and maybe it was worth some attention.
The feedback we've gotten on translations, on like LLM translations for stuff, is interesting because it's, for a long time we would use a paid service where we would send our strings out and it would go to actual people and they would translate, all the strings, and we'd get them back and done. And so there was like a review process there, and we'd pay actual human translators for that. And the feedback we'd get from that usually it would be, well, nobody would say it this way in German or whatever. And so we go back to the translator and say, this is the feedback we got. They said nobody would say it this way in German. And they're like, well, yeah, but we translated exactly what the English was. Like, this is, the English says this, and this is what that would be in German. And, people in German would say it this other way, sure. But that's, you weren't paying us to change what it says. You were paying us to translate it. And so the feedback we're getting from the LLM translations is actually exactly the same. It's like, nobody would say it this way in German. It ends up being the same. So they're
also,
right.
So some languages they come back with like, this one screen of yours is totally casual, where the other screens are like formal, and it's weird. Like, okay,
all right. So they're probably right. We'll change it. We'll fix it. Okay.
I don't even know whether we want to be casual or formal.
Consistent's good.
Consistent's good. All right, Ryan asked, does Speedify software have to do anything special to work with internet connections on different frequencies, like 2.4 versus 6 gigahertz versus cellular versus 5G ultra-wideband?
No, not really. I mean, I think things are so variable. I think one of the hardest things that Speedify has to do is just kind of deal with changing conditions, where you can have, 5G ultra wideband that's really fast, and then all of a sudden 30 seconds later it's really slow, and it just happens that you're in your car, or you're walking in, you turn the corner at the mall and you're not by that tower anymore. So just dealing with changing conditions of all this stuff is probably the hardest thing we have to do.
I've heard and read some reports that Starlink is ruining our night sky due to the sheer amount of satellites they're sending up. How true is that? Light pollution, radio pollution?
It's pretty true.
It's right. I see them. Look at my eyes. And I look up and I see them. I can see them with my bare eyes. I mean, there's no way that they're not. I mean, they did a few things. They used to put up silver satellites. And now they paint them black, which is a tiny improvement. But right after sunset, where, you're in the dark, the sky gets dark, but the satellites in space are still in the sunlight, you see them. You see them whizzing by, looking like shooting stars, and they're not shooting stars. They're just thousands and thousands of Starlink satellites. Is your horizon ruined by cell phone towers?
In relation to the sky being ruined by satellites? So
it's funny to me. In New Jersey, at one point, some people there got really worked up about how ugly cell phone towers are. So they made the cell phone companies put in towers that were disguised to look like trees. But they are so awful that they grab my attention. I'm like, what the hell is that thing? Oh, it's a cell phone tower that's disguised to look at a tree. I don't notice trees. I don't notice cell phone towers. But cell phone towers that are trying to look like trees, what the heck is that thing?
We have one of those by us. It's a giant metal pine tree, and it looks absurd. I know. But yeah, anybody doing deep space, observation, you have to look at a tiny part of the sky for, if you're doing it from Earth, you do it for hours, and you do your best to sort of track it through the sky, and they just can't do that anymore. That's my understanding.
Those guys are catching single photons.
Right. Yeah. So
how dim these things they're looking at are absurd. You can't really imagine.
Right. So I think a lot of
NASA's doing some they've been planning and setting up for they're planning to start dropping robotic telescopes on the far side of the moon.
Yeah.
Right, so they can't pick up anything from us, right? They won't be able to send anything home. They're gonna have to they'll put one satellite or two satellites in orbit around the moon, and when it goes by, they'll quickly upload all the pictures they took And then when it comes back around the moon, it'll send it back to Earth. That's the levels they're reaching. But not to be anti-whatever. Is that okay? I mean, astronomy is like important, but getting internet to billions of people is important. And so maybe just the astronomers have to move their satellites to the far side of the moon. I think I'm going to call it. Thank you, Brian. Thank you to all of you guys. Really appreciate the discussion, the questions. This was fun. So I will see you guys next week.